Ugh. All right, let's start. So we're going to start a new topic, that is the firm theory. We're now trying to understand how firms make decisions. Now, for us to proceed to study firms' behavior, firms, they all have one objective. That is, people setting up companies for one reason. That is, firms are all profit-seeking entities. We use pi symbol. And profits is a difference between total revenue and total cost. So when you have the total revenue minus the total cost, the difference is the profit. And now, revenue depends on the price per unit of outputs and the quantity of outputs. So profits, we use pi as a symbol, which is the difference between the total revenue minus the total cost. And total revenue depends on the price of the outputs and the quantity of the output sold. And total cost depends on input used and input prices. That is how much it costs to get the input and how much input you use to produce the output, and quantity of outputs produced. So if you look at these two items, total revenue and total cost, the quantity of output sold, quantity of output produced, they are in both terms in the profit equation. And now we're going to start with the cost side first. The reason is, in different markets, the price may be different. It depends on the market power of the firm. And we leave this for later chapters, because this is pretty generic for all types of firms that we study in this course. And therefore, this is something that we can apply to all different market structures. And that's why we study the cost side first. And now, production function. Now, what is a production function? It is simply telling us the transformation of inputs into outputs. So in other words, if we imagine this is a factory, and in this factory is taking place, in which the factory will require outputs. And through the production process, the factory will be able to produce output. So the production function tells us how much output can be produced based on how much input we use. So in other words, it is telling us how the inputs are being transformed into output. So in the production function, what do we have is first inputs. That is, what kind of inputs are required to produce output? And the technology. So with different technology, even though we're having the same inputs, but the output will be different. So now, what are we talking about when it comes to inputs? Inputs. We assume there are two inputs. One is labor inputs, workers. Next, capital inputs, equipment, factories, tools, machines. These are capital. That is labor and capital. Now, some students would argue, if we want to produce output, of course, we need energy, like electricity, and we need raw materials. Yes, that would be typically the case. But if we want to demonstrate the idea about production function in a graph, and the graph is only two-dimensional, and therefore we can only choose two inputs to demonstrate the idea, and we're going to choose the two most important, that is labor and capital. And now, next, time horizons. Short run and long run. Is K for capital. This is the convention in economics. C, we save that for cost. So, for the time horizon, short run and long run. Now, in economics, short run and long run, they are not being distinguished by how many months. The way we distinguish between short run and long run is that long means long enough for all inputs to be able to adjust. So long run means all inputs would have enough time to adjust. So in other words, short run means at least one input does not have enough time to adjust, then it is short run. So time horizons are not distinguished by the calendar month or days. It means using different quantity of inputs. So, for example, in a factory, when you adjust labor inputs, that means you want to hire more workers, or you want to lay off some of your workers, or you want your workers to work overtime. This is what we mean by adjusting an input. That is, using more or less of that input. So, if we have two inputs, in the long run, labor and capital, are variable. That means we can vary, we can adjust the amount of labor and capital used in the production process. But in the short run, one of these two inputs cannot be adjusted or varied. So typically, labor and capital, then capital will be the one that is not able to adjust. Because if you look at how long it takes for a factory to adjust labor input compared to adjusting capital input, a factory can easily adjust labor input, hiring more workers or firing some of the workers. It can be done within a week or even days. But changing capital, like machines or building a new factories, it will take much longer time than hiring or firing of workers. And therefore, if we are under time constraints, that we don't have enough time to change the input, most likely it will be the capital, like the size of the factory, that we don't have enough time to adjust compared to labor. The bar on top means it is fixed, because we don't have time to adjust. So we have to do with whatever we have. So the K bar, the bar on top, means this quantity is fixed. That is, if you are being hired to run a factory, what you can do and what you can produce with that factory is just how many workers you want to hire, because the factory size is fixed in the short run. You cannot have time to change the machines or build a larger factory or downsize your factory. You can only have time to adjust labor input, that is, hiring more workers or lay off some of your workers. And now, since in the short run, the size of the factory is fixed, and we only need to pay attention to labor input, that is an easier task. And that's why we start off with the discussion of the short run production function. So the flow is like this. First, we talk about production. And from production, we talk about productivity. From productivity, we can tell about the cost. So this is the flow. And in the short run, factory size is fixed. That is K bar. So in the short run, you can only do with whatever you have in your factory. The size of the factory is fixed. The machines, everything in the factory is fixed. You don't have time to change machines. or build a large downsize your factory. In other words, outputs may change only if labor inputs is changed. Because for a fixed factory, you want to produce more outputs, you hire more workers or ask your workers to work overtime. If you want to scale back, that is, reduce output, you lay off some of your workers. And therefore, in the short run, output depends only on labor inputs. If you want to change the output that you produce, you only need to change the labor inputs that you use. And now, next, the relationship between outputs and labor inputs. Yeah, we're getting there. Too many cooks spoil the broth. Well, you can sell all your machines, but in the short run, you don't have time to do it. Now, don't forget, in the real world, a lot of the machines in factories, they are tailor-made. Just like automaking, the robots are tailor-made. Well, machines can be mobile. You can take the machines out and sell the machines, but in the short run, you simply don't have enough time to do that. Right. You cannot adjust the number of machines. In the short run, the number of machines, the factory size is fixed. You can only change how many workers you hire. So now, in the short run, if this is labor inputs, yeah, in the long run, you have enough time to build a larger factory or sell the factory and get out of business. And this is the outputs. So the relationship between labor inputs and the outputs looks like this. You cut the bell in half, the half bell shape. This is what we call the total product of labor curve. That is the relationship between labor inputs and output a factory can produce. And don't forget, in short run, the factory size is fixed. In other words, this relationship is for this particular factory size. So for this given factory size, if you hire more workers, output will change in this direction. And now next, why it is a half bell shape, this total product of labor curve, why it is not a square, circle, why this is like a half bell shape. So let's examine the shape. Now don't forget, always keep in mind in the short run, this is for a particular factory size. So this relationship between labor input and output is true for this particular factory size. And now, first, what do we observe? In here, this curve is flat. And up there, this curve is also flat. Now, what does it mean when this total product of labor curve is flat? That means increased labor input, not much increase in output. It is flat in the beginning, it is flat at the top. That is, when you increase more labor input, the increase in output is not that much. Now, why is that the case? Remember, this relationship is based on this factory size. And in here, for this given factory size, when you have too few workers, like you have machines in your factory, and you only hire 5 or 6 workers, you are actually having what we call underutilization. Of the capacity, which is the size of the factory. So if you have 100 machines in your factory, that will be your capacity. Higher. So if you have 100 machines and you only hire 5 or 6 workers, then you underutilize the capacity of the factory. And therefore, the output would not be rising fast. The opposite is true here. For this given size, given capacity, if you hire too many workers, then you overutilize of the capacity. Now, whether you underutilize your capacity in the beginning or in the end, if you keep on hiring more and more workers, you end up overutilizing the capacity. Either way, the conclusion is simple. It's inefficient. So why? Well, if you have machines sitting idle and not using them, you're not efficiently using your resources. And if you have too many workers for that given factory size, it is not efficient either, because down here you have idled machines that you don't use. That is not efficient. Up here you have overcrowding. It's not efficient either, because don't forget, like earlier some of your fellow classmates said, too many cooks spoil the broth in the kitchen. So this capacity is like the size of the kitchen in a restaurant. If you hire only one chef in the kitchen, it is not efficient. But if you hire too many chefs, they bump into each other. It is not efficient either. And in the middle, in here, it is steep. That means efficiency improves when you better utilize the capacity. And now, let's get into some terms. Well, up here, it will plateau. But once it plateaus, that is flat out, this would not be interesting anymore. And now, the concept of productivity measurements. To measure productivities, we can measure it through what we call marginal products of labor. Or average products of labor. Productivity measurements. One is measuring the marginal productivity. The other one is measuring the average productivity. So, definition. Marginal productivity of labor, the change in the quantity of outputs over the change in the labor inputs. In other words, suppose you increase 3 more workers in the factory. So you hire 3 more workers, and the output rising by 21 units. So using 3 more workers, output increases by 21 units, and therefore the marginal contribution of each worker is actually 7 units. So marginal is about ratio of changes. That is the change in the labor inputs and then the change in the outputs. Average, on the other hand, is the ratio totals, not changes, which is defined as the total outputs divided by the total labor inputs. For example, in your factory, if you hire 50 workers and you produce 2,000 units of output, then on average, each worker produces 40 units of output. So these are the 2 productivity measurements. One is about changes. One is about total. And now, we can find these 2 productivity measurements from the total product curve. First, the marginal product of labor, change in output, change in labor input. What is this ratio? This is rise over run. In other words, the marginal product of labor is actually the slope of the total product of labor curve. That is Q, not G. This is the quantity of outputs. So the marginal product of labor is a change in the output over the change in labor input, and output is on the vertical axis, and therefore the change in output is a rise. Labor is on the horizontal axis. So when you change the labor input, you are running. So rise over run is a slope of this total product of labor curve. So what we see in here is that initially we said this is flat. Therefore, you have low marginal product of labor. And at the top, this is also flat. That means you also have low marginal product of labor. And then, as we move up, it gets steeper. That means for this given factory size, as we hire more labor, the marginal product of labor is actually increasing. Why would that happen? Well, because of the division of labor. For a given factory size, the more workers you hire, the more capable you can divide the task. Everyone will be focusing on a short task. Just like the assembly line concept. Why Henry Ford was so successful? Yes, specialization. Why Henry Ford was so successful to bring the Model T at such a low price more than 100 years ago? Because he was using the assembly line concept, that is, division of labor. Every worker along the assembly line was responsible of only one small task. Now imagine, if you are doing the same task thousands of times day out, you will find a better way to do it faster and do it better. And that is a division of labor, resulting in specialization. So, as the factory hires more workers, it will improve the marginal product of labor. That is, when we better utilize the capacity, division allows specialization, making each worker at the margin more productive. But in the end, it is getting flat again. That means beyond a certain point, it gets flatter. Then the marginal product of labor will be falling. There must be a turning point. And that turning point is somewhere in here. That is, when the marginal product of labor increases and then reaching this point where you get the maximum marginal product of labor. And once you reach the maximum, then it begins to decline. So this is where the textbook referred to as diminishing marginal product of labor. This diminishing marginal product of labor is because of overcrowding or congestion. Now in geometry, if the slope is getting steeper and steeper, and then reaching the maximum value for the slope, and then it begins to decline, this is what we call the point of inflection. General term, we call that the turning point. From increasing marginal product of labor. At that point, it becomes decreasing or diminishing marginal product of labor. And now, from this graph, we can plot the marginal product of labor. So suppose this is the labor input LM, in which we said this is where we get the maximum marginal product of labor. So suppose this is where we have the maximum marginal product of labor at this point. And to the left, as we hire more and more workers, the marginal product of labor is rising, is increasing, which is like this. It is increasing. And then it reaches the maximum. And once we have reached the maximum, the turning point, then hiring more workers, we run into diminishing marginal product of labor. That is, marginal product of labor will be falling. And this is the marginal product of labor curve based on the slope of the total product of labor curve. So now we have learned how to derive or figure out the marginal product of labor from the total product of labor curve. Next, this is the level of labor input that will get us the maximum marginal product of labor. Next, the average product of labor. So the average product of labor, output divided by labor input. And how can we derive this from the total product curve? The marginal product or the slope is getting steeper and steeper. That is rising marginal product. And then beyond this turning point, the slope is getting flatter. That means falling marginal product. And now, how can we figure out the average product of labor from this total product of labor curve? The trick is draw a straight line from the origin that touches the total product of labor curve. And from this straight line from the origin, if you look at this level of labor inputs and this level of output, this is the rise and this is the run. In other words, the slope of this straight line from origin, that touches the total product of labor curve, is actually the average product of labor, this slope. Well, you can draw any line. So if you draw a line like this, it will touch the total product curve in here. That means at this level of labor inputs relative to this output, this slope will give you the average product. As you can see, as we increase labor inputs from L1 to L2, the slope of the straight line from the origin is actually getting steeper. In other words, increasing average product of labor. Starting from the origin, if you draw a straight line touching the total product curve, and you can see the straight line is actually getting steeper and steeper and steeper until it reaches the middle. So this is actually the slope with the maximum average product of labor. It's like right at the cliff. So in other words, the average product of labor will be rising all the way up to this point to reach the maximum. And beyond this point, the average product of labor will be falling again on this point. And now, we can use this observation to help us plot the average product of labor curve. Let's call this labor input LA, because in here you get the maximum average product of labor. And if this represents the maximum average product of labor, down here in the graph below, then what do we see is, as we increase labor inputs, the average product of labor is increasing up to this point. That means the average product of labor is increasing up to this point to reach the maximum. And then beyond this maximum, if we continue to use more labor inputs, then the average product of labor will fall, which is like this. So this is the average product of labor curve. And now, how do we figure out the relative position between the marginal product of labor and the average product of labor. First, we said that somewhere in here, this is where we get the maximum marginal product of labor. And then somewhere in here, we get the maximum labor. And now, if we want to plot the marginal product of labor and the average product of labor curves down here, would they be positioned relative to each other? First, notice at this point, that is the tangency. That is, the total product curve is actually tangent to the straight line from the origin at this point, which tells us the slope of this straight line is the same as the slope of the total product curve. So when this straight line from the origin has the same slope as the total product curve at this point, then this point must also be the marginal product of labor. Is it freezing still? Okay, I'll log off and log back in. So in here, what do we see is this is the tangency point. That means the slope of the total product curve is the same as the slope of this straight line. The slope of the straight line is the average product. The slope of the total product curve is the marginal product. And now we see that when the average product is reaching the maximum, it is equals to the marginal product. We get one connection between the two, and we need more. First, we know that the marginal product of labor curve looks like this. And now, where is the average product? To figure that out, we need the relationship between marginal and average. When marginal is greater than average, the average will rise. Now, what is going on? Imagine a wrestling team, 2 members, and one member weighing in 300 pounds, the other member 240 pounds, and therefore the average is 270. Now, if there is a marginal member joining this tag team in wrestling, and this guy weighs in 'Look at this example, then you understand. So if there's a marginal member joining this tag team, and this guy weighs 330 pounds, so now marginal is greater than average. So this is marginal. The weight of this marginal member is greater than the average of these 2 members. And if you add this marginal member to the tag team, and now the average will become 290. That means the average would rise compared to 270. So adding the marginal is greater than the existing average. It's going to pull up the average. And marginal equals to average. Then the average remains the same. And when marginal is less than the average will decline. Now, using this, we can figure out the relative position between the marginal and average product of labor. At this point, we know this is maximum average product of labor. In other words, before we reach this point, the average product must be rising, which is exactly what we said. In here, in this region, marginal product of labor is higher than the average product of labor, and the average product is rising. And then at the maximum, the average product of labor equals to the marginal product of labor. From this, the average product of labor is declining. And in this region, the average product of labor, that is the margin of labor, is lower than the average product of labor. And that's why the average is falling. So, total product curve, we can figure out the average product and the marginal product of labor. The next step is use these two curves to help us figure out the cost curves. So let's take a All right, let's start. So now we're going to connect productivity and cost. Now, the general idea or the intuition is like this. Increasing productivity means improves efficiency. In other words, same use of inputs results in more outputs. If the productivity of an input increases, that means improves efficiency, because using the same inputs, now you can produce more outputs. And therefore, when efficiency improves, the corresponding cost will fall. This is the general intuition. And now, we're going to work through the details. The total cost depends on input price. Total cost depends on input prices and input use. And input prices, small r, is the cost per unit of capital. Small w is the cost per unit of labor. And input use, how much labor you use, and how much capital you use. In other words, the total cost is how much capital you use and how much per unit of capital will cost you, plus how much labor you use and how much each unit of labor will cost you. So this is a total cost equation. And now, let's look at the total cost equation from the short run perspective. In the short run, capital is fixed, and therefore the short run total cost in the short run, the factory size is fixed. And therefore, the total cost in the short run total cost is equal to the cost per unit of capital multiplied by the fixed factory size in the short run. The cost of labor per unit times the number of units of labor used. And in the short run, this is the fixed input. This is the variable input. Because in the short run, you can vary how much labor input you use. As a result, this represents the fixed cost. And this represents the variable cost. And therefore, the short run total cost is equal to the fixed cost plus the variable cost. And now, the change in the short run total cost is equal to the change in the variable cost, because this is fixed cost, it doesn't change. So if it doesn't change, whatever change on the left-hand side can only come from the change in the variable cost. So therefore, the change in the short run total cost is equal to the change in the variable cost, because fixed cost doesn't change. And that's why we call that fixed cost. And therefore, if we divide this by the change in the output on both sides, what do we have in here? It's actually the short run marginal cost. That is, how much change in the short run total cost when we change output we produce. So that is the short run marginal cost. And now, using this relationship, the short run marginal cost equals to the change in the short run total cost, change in the output, which is the change in the variable cost, change in the output. And now, variable cost is equal to W times L. And for given cost of cost of labor per unit, the change in the variable cost is simply equals to the cost per unit of labor multiplied by the change in the use of labor. That is, if you're going to use 5 more workers and each worker costs you $100, and therefore the variable cost would rise by $500. These $100 per worker, the cost is given. Which implies the change in variable cost, change labor inputs is equal to W. And now we need, if we divide the numerator in here by the change in labor, and the numerator also divided by the change in labor, it doesn't change the expression. Then in the numerator, we have W. In the denominator, we learned that is the marginal product of labor. Now, what we have derived is that short-run marginal cost is related to the unit cost of labor inputs divided by the marginal product of labor. And now, you can see the relationship between productivity and the corresponding cost. In other words, if we have an increase in the marginal products of labor, that is a larger denominator in this ratio, then the entire ratio drop. That is, the marginal cost will fall. Next, average variable cost. Is equal to the variable cost divided by the outputs, which is equals to W times L divided by output. And if we divide the numerator by L and the denominator also by L, what do we get? W over average product of labor. In other words, now we are connecting the average product of labor to the average variable cost. And when the average product of labor increases, the entire ratio will drop. That means the average variable cost will fall. Now we have what we need to connect the marginal product of labor to the short-run marginal cost, to connect the average product of labor to the average variable cost. Now we can plot them. And now, how can we stack up labor outputs? So these are two different variables. How can we stack them up like this? The reason why we can do it is because, according to the total product of labor curve, if we have this input, it corresponds to one level of output. So this is a one-on-one relationship. And that's why we can align them in these two graphs. All right. And now, what do we see? Short-run marginal cost equals to the wage divided by marginal product of labor. And the average variable cost equals to the unit cost of labor divided by the average product of labor. As cost must be falling. So when it reaches the maximum up here, down here, it must be the minimum, because productivity and cost, they move in opposite direction. So when the productivity measured at the margin is maximum, then the corresponding cost must be at the lowest. And when the marginal product of labor drops, then the short-run marginal cost be rising. So this is the short-run marginal curve. The same is true about average product. When average product is rising, then average variable be falling. And when the average product of labor reaching the maximum, then the average variable cost must be reaching the minimum. And when average product of labor is falling, then the average variable cost must be rising. So, productivity and corresponding cost measurement are inversely related. So the productivity measurement and the corresponding cost measurement, they're inversely related to each other. And that's why if we fold this in half in here, this is like a mirror. So the image on the top is being mirrored down here inversely in the bottom. So it helps us figure out the first two cost curves from these productivity cost curves. So from these productivity curves, we figured out the first two cost curves. And we need to figure out the rest. Next, the short cost equals to the fixed cost plus the variable cost. And if we divide everything by output, this becomes short run average cost. And this is the average fixed cost. And variable cost. That is, now we are measuring everything per unit of output. We have figured out the average variable cost. And therefore, if we can figure out the average fixed cost, then we can figure out the short run average cost. So now, next, how can we figure out the average fixed cost? Average fixed cost is equal to fixed cost divided by output. And this does not change as output changes. And that's why we call it the fixed cost. And therefore, as output increases, that is, the denominator increases, numerator doesn't change, and this ratio will drop. In other words, when we increase output, the average fixed cost is always falling. In accounting, this is called spreading. The overhead being the fixed cost. Yes, it is downward sloping. So if we plot this out, this is what the average fixed cost would look like. And now, common mistake. Pay attention. The average fixed cost tapers off, but never touches the horizontal axis. That is, the average fixed cost is always greater than 0. And average fixed cost is equal to fixed cost divided by output. And therefore, average fixed cost equal to 0 if output equals to infinity. Anything divided by infinity is 0. Output equals to infinity. That is impossible because we have limited resources. So with limited resources, there is no way that we can produce unlimited quantity of outputs. And therefore, average fixed cost will never touch the horizontal axis. And if you let the average fixed cost touch the horizontal axis in the exam, marks will be deducted. And now we have figured out the average fixed cost. So the short run average cost equals the average fixed cost plus the average variable cost. In other words, this one is simply equals to we stack average fixed cost on top of the average variable cost vertically. That is, and at any level of outputs. So now, we know the relative positions of everything. Let's plot the short run average cost. We figure out the short run marginal cost, and we also figure out the short run average cost. And now, the short run average cost will look like this. Because this represents the average fixed cost. And average fixed cost is declining. And that's why these two are getting closer and closer, but they never touch. Now, common mistake exam. A lot of the time, students draw this graph: short run marginal cost, average variable cost, short run average cost, as if the short run average cost and the average variable cost are parallel. This is wrong, because if the short run average cost and the average variable cost curve are parallel, then the average fixed cost must be constant. That is not true. That's why in the exam, if you draw these cost curves like this, with these two cost curves parallel to each other, marks will be deducted. And now, how do we know that the short run marginal cost is going through the minimum of the short run average cost? How do we know they cross each other at this point? Well, short run average cost is greater than the average variable cost. And in this region, it is also greater than the short-run marginal cost. That is, marginal less than average. The average will fall. Well, this is what happened in here. Marginal less than average, average will fall. And when marginal greater than average, average would rise. So the turning point only happened at the minimum of the short-run average cost. And now, what does it mean? The minimum short-run average cost. The minimum short-run average cost tells us this is the lowest cost per unit of outputs produced, i.e., the most efficient level of outputs. Remember, efficiency and cost, they go hand in hand in opposite direction. When the cost is the lowest, that means you get the maximum efficiency. That is the most efficient. Why is that? Well, because this is the designated capacity of the given factory size. So this factory is designed to produce this output. And therefore, if the firm is actually producing this output in this factory size, then it is the most efficient way to produce, because this is what the factory is built for, this particular capacity. Now, we have the short-run marginal cost, average variable cost, short-run average cost, they don't lie on each other. They simply intersect. The short-run marginal cost goes through the minimum of the short-run average cost. And we know short-run marginal cost equals W over marginal product of labor. And the average variable cost equals to W over average product of labor. And the average fixed cost is equal to the fixed cost over the output, which is this. And the short-run average cost equals to the average fixed cost plus the average variable cost. And now, if we have an increase in cost of capital per unit, it impacts our cost curves. You look at these 4 cost measurements. The only place we can see R is here. And therefore, increase the cost of capital per unit is going to increase the average fixed cost. Increase the average fixed cost is going to increase the short-run average cost. In other words, increase R, it will only increase the short-run average cost. That's it. Next, when there's an increase in the cost per unit labor input, it is going to affect a lot of things, because first, it appears on the short-run marginal cost. It will increase the short-run marginal cost. Next, it appears on the average variable cost. And when you change the average variable cost, it will also change the short-run average cost. In other words, changing the cost of labor input per unit. It shifts all these 3 cost curves up. So increase the unit cost of capital input, like interest rate, compared to the increase in the unit cost of labor, like minimum wage. Look at this. This is like the interest rate going up. This is like the minimum wage going up. If you run your own business, which one would you hate most? Of course, this one. Because changing the interest rate, you're only dealing with one curve shifting. But if the government increases the minimum wage, you have to deal with 3 cost curves shifting at the same time. That will give you triple the headache. And now you understand why several years ago, when the Ontario government raised the minimum wage, a lot of the businesses, they got really angry with the government because they tripled the headache. And now, short-run and long-run relationship. How are they being related to each other? Short run and long run. In the short run, capital is fixed and labor is variable. In the long run, capital and labor are variable. In other words, in the long run, it is more flexible, because in the long run, firms would have enough time to change. In the short run, that means it is less flexible. Imagine the difference between these two. So when you are and you want to unbutton, if you are flexible, that means if you had one hand tied, you would not be able to take off your winter jacket as fast as when you have two hands free to do it. And therefore, in the long run, because it is more flexible, and therefore it is also more cost efficient. In other words, the long run cost must be less than or at most equals to the short run cost. Because in the long run, you are more flexible. When you are more flexible, you should be able to reduce the cost increase more than what you can do in the short run. And now, if this is short run average cost based on this factory size, and if we have enough time to use a larger factory, the cost may be lower. Or we can choose an even larger factory. So these three different factory sizes will give us different cost per unit. If you are in the short run, you are here. But if you have time to adjust, you may be able to choose this one or that one. And now, if you have a lot of time and you have a lot of choices to make, that means you can choose this factory, this factory, this factory, this factory. You can choose any different factory sizes as you like. And therefore, in the long run, you can choose this factory size, or this factory size when you are more flexible. Then the long run cost the long run average cost must be less than or at most equal to the short run average cost at every level of output. Because in the long run, you are more flexible. We will pick that up next time. We will just need another 10 minutes to finish this chapter. So let's stop here today. And don't forget, there's a tutorial afterwards. All right? You're welcome. I'll see you next week. Okay, so I'm going to stop recording so you would have time to switch over to the tutorial session. All right, so I'm going to stop recording now and log off from this session. I'll see everyone next week.